Good morning, everyone. I'm Sangipriya B from the Department of CSE IoT, working in a college of SNS College of Technology. Today, we are going to see about tree data structure, and the topic is binary search tree. Tree data structure is nothing but a tree where it has a root node, parent node, and a child node. Uh, we can easily we uses the tree for an easy access of the data where the data are arranged in an order that the left subtree consists of a lesser node and the right subtree consists of the greater node, and we can have an insertion and the deletion part in it. For more reference, you can refer to my previous playlist videos where I have explained detailedly about the tree data structures and the types of tree data structures which we are using in a data structure. And here we are going to see the topic of binary search tree. In previous video, we have discussed about heap. Heap is nothing. Heap is a order where it consists of two types of heap, that is mini heap and a maximum heap. Where the mini heap is used for the function of greater than nodes and the greater nodes than the root node, and next one is the maximum heap where we uses the maximum heap for the root node as a maximum value and the parent node and the child node as a minimum value. If it occurs again, and we are going to swap it and do it. Here we have this. We are going to see about a binary search tree, and here we are considering a real-time example. The first one is that for considering Tom is having a place which holds the data set, and Tom's want to add more data to the data set. But he Tom also wants the data to be stored in a sorted manner in a hierarchical way. What order should Tom uses? Here comes the binary tree for the solution. Here the binary tree, only smaller values should be in a left subtree and only larger value should be in a right subtree. That is, here we have mentioned in a diagram, the root node with the value k is a root node, and the left subtree contains only smaller value, right subtree contains only the larger value. All values greater than the k. Next, here is a binary search tree example. We are having a 45 as a root node. Comparing to the 45, the next node is a 20, means it should be 45 is less than 20. So we are inserting it in your left side. And next, we are taking 60. It is comparatively high than the 45. So we are inserting it into a right side. Next, we are taking 70. It is comparatively high than the 45 and comparatively high than the 60. So it is inserted right side of a 60, and 50 is inserted in a left side of a left side of a 50, and 20 is comparatively high than the 16, so it is inserted in the left side, and 40 is comparatively high than the 20, so it is inserted in a right side of the 20. So it is the order where we are using for the binary search tree. Here, the application of the binary search tree is calculating the expression tree. Tree means where we have an operand and an operations. The operations will be considered as a root. Operands will be considered as a root node, and the operations will be considered as a child node. Here, and next one is expressing the arithmetic expression. Next one is for dynamic sorting, and next one is for virtual memory area management, and next one is the IP addressing indexing, where we can arrange the IP address from the smaller to larger, so it could be easy for us to allocate the IP for the individuals or a group of persons to access it easily. Here in this example, which follows the binary tree. For example, the first one, if we consider 2 is greater than 7, but it is placed in a left position, so obviously it is not the binary tree. And here 8 is greater than the 8 is less greater than 3, it's ordered placedly, then correctly 10, it is also correctly placed, and next one is 1 6 correctly placed, and next one is 4 7 correctly placed. 14 and 13 is also correctly placed. And here it comes. The 42 and 68 does not contains the same value. So the C is not the option. So obviously the B is the correct one for the binary search tree. Next one, in this binary search tree, we have an operation of insertion, deletion, create, and a display. 10, 12, 5, 4, 28, 7, 15, 13 are all numbers which we should included as we should be inserting. And next one, we are giving you an assignment where you can, for 10 is considered as an root node and balance you should be placed. Kindly keep reminder that left node should contains the smaller value than the root node and right node should contains the larger value than the root node. Hope you all enjoyed this video. Let's see in the next video. And here I have given some reference links for the lecture which I have taken today. Thank you so much. Have a nice day.